Hi, my name is Nestor. Let's cover a few articles today about what's going on in the realm of artificial intelligence. And stick with me to the end for a real mind blowing article. So, first off, we'll look at Meta and their massively multilingual speech project that has expanded language coverage and improved speech recognition and synthesis models. So, in this article, Uh, it starts as Meta's open source speech AI model support over 1,100 languages. Written by Ryan, here, senior editor at the TechForge Media. So I found this very interesting article because it said they're trying to get this AI to learn these different languages, but they don't have all the data on the nuances of the language and how like how what are the specific labels for specific words in some of these languages. So instead, what they did, right here, it says they basically, these translations, they used like religious texts like the Bible, which was translated into many different languages. And what they did is these translations provided publicly available audio recordings. They used audio recordings of people reading the text, enabling the creation of a data set comprised of readings of the New Testament in over 1,100 languages. So they used the audio recordings, fed it through the artificial intelligence to create a set of data that the large language model can go through and try to start making connections and patterns on what the language is. It says here, by including unlabeled recordings of other religious readings, the project expanded the language coverage to recognize over 4,000 languages. So they're teaching the AI languages by using audio recordings of people in their native language reading the Bible and other religious texts. So, how did they do this? Basically, they used by training self supervised models on approximately 500,000 hours of speech data across 1,400 languages. The project significantly reduced the reliance on labeled data. So, since they didn't have all the labels for all these different words in all these different languages, by just applying the audio of people speaking, they were able to train these models on those languages. And so now they're able to produce a text to speech for about 1,100 languages. So I found that very interesting. The MMS model achieved better performance than OpenAI's Whisper, with half the word error rate and support for 11 times more language. So the race is on to see who's on top in artificial intelligence. So it's very exciting to see all the new developments and what's going on in AI. The next project we're going to look at, the next article, is in the field of medicine. Using AI, scientists find a drug that could combat drug resistant infections. So, what did they do? AI was used by MIT and the McMaster University research to identify a new antibiotic that can kill drug resistant Acinetobacter baumannii, a bacterium often found in hospitals causing pneumonia, meningitis, and other severe infections. They obtained training data for their computational model. The researchers exposed A. baumannii grown in a lab dish to about 7,500 different chemical compounds to see which ones could inhibit growth of this microbe. Then they fed the structure of each molecule into the model. They also told the model whether each structure could inhibit bacterial growth or not. This allowed the algorithm to learn chemical features associated with growth inhibition. Once the model was trained, the researchers used it to analyze a set of 6,680 compounds it had not seen before, which came from a drug repurposing hub at the Broad Institute. This analysis, which took less than 2 hours, yielded a few hundred top hits. One of these, the researchers chose 240 to test experimentally in a lab, focused on compounds with structures that were different from those of existing antibiotics or molecules from the training data. So basically, with these structures, they found that there was a drug that is used for diabetes that is actually very helpful as as an antibiotic, really, for this specific bacterium. So I found this pretty interesting that in 2 hours after training the model, they were able to identify a compound from already pre-existing compounds that we have and drugs that we have available to really repurpose it for something that they were not able to find before. So this really reduces the time to produce any kind of drugs or maybe even possible cures in the future. So this is very interesting how artificial intelligence is being used in the medical fields, specifically pertaining to drug development and drug repurposing. The next article we're going to cover is how this tech is also being used right now in some news articles. So this next article shows how AI is slowly being implemented little by little in every little thing that we do. This article says a news app Artifact can now summarize stories using AI, including in fun styles, like summarize this article as if I was a 5-year-old, and the AI will automatically get all the information from the article and give you a brief summary. And it's very brief. Now, I didn't know about this application until I was doing research on some of the things that AI is being used this week. And this app, I guess it was created by the Instagram founders, and it's an aggregator of news specifically tailored to you. Now, it's an iOS and Android app, but I think it still lacks a little bit of functionality. Um, you could look at the article, you could push a button, and it'll give you a 3-point summary of what the article is, but I don't think it gives you enough context to really get a good grasp of the article. But it's pretty interesting. I did look at it. It just goes to show that AI is being implemented more and more into things that we're doing. Now, if you use this app, this might be interesting for you to play with and see how good the AI is um, at summarizing some of these articles. But it shows that as this technology gets implemented in more of what we do daily, it's going to help us be more efficient and help us learn things faster and be quicker at the things that we're trying to learn. It's important to note that the summaries don't replace the utility of having the full text of the article. The company's blog post reads, AI is powerful, but from time to time can make mistakes. So it's important to verify the summary matches the article as you read the full text. So you definitely want to read the text. You don't want to go by just a little brief summary that it tells you, because it is very brief, and that also depends on the way they programmed it, the way they prompted the AI to respond to those articles, how I could summarize it, because you can make a better prompt so that the language model, so the model can give you a better, more concise, um, or more elaborate summary. So I found that to be pretty interesting if you use this application. Okay, the final and mind-blowing article, if you stuck around, we're going to cover right now. I think it's pretty incredible what they're able to do, and it goes to show what the future holds and the potential that it can have uh, for day-to-day society. Okay, this last article to me was mind blowing and scary at the same time. let's look at this article real quick from the Vice. AI reconstructs high quality video directly from brain readings in a study. So this is pretty incredible. So they used a couple different technologies to marry it together with artificial intelligence to kind of develop this. How did they do this? Let's go down here and look at this. Researchers from this place, I'm not going to say it because I'll butcher the name, and this place from the National University of Singapore and the Chinese University of Hong Kong used fMRI data and the text-to-image AI model Stable Diffusion. Now, if you've never heard of Stable Diffusion, you can look it up. I'll do some videos on Stable Diffusion coming soon. To create a model called MinD video that generates video from brain readings. So how did they get these brain readings? Well, first of all, MinD is defined by the researchers as a two-module pipeline designed to bridge the gap between image and video brain decoding. So to train this system, the researchers used a publicly available data set containing videos and fMRI brain readings from test subjects who watched them. So they basically had images and they were getting fMRI readings from these individuals, and they were seeing how the brain reacts to these certain images. And then basically what they did was take this data and hand it over to an artificial intelligence and said, hey, this brain reading was an image of a cat. And here it was again by a different individual, and here it was again by a different individual. And what's good about LLMs, or large language models, and artificial intelligence, they're good at getting the data and finding patterns. So it was able to find the pattern, and then when attached to Stable Diffusion, which is a text to image artificial intelligence, they were able to basically, from the brain patterns from the fMRI, they were able to develop images, the same images that were being shown to the individuals. So, and not only images, but also video. So videos published by the researchers show the original video of a horse in a field, and then a reconstructed video of a more vibrant colored version of the horse. So this is still pretty crude, but it's pretty interesting, and I found it pretty wild that you can just think about what say a film or a movie, and imagine an AI plugged in and now showing you the film that you're thinking about. That would be crazy. If you found this video informative, please tap the like button, consider subscribing for more content like this about this fast changing industry of artificial intelligence. If you have any comments about some of these articles, go ahead and write them down below. Let me know what you think about these things that's going on right now. Also, thanks again for sticking with me to the end and allowing me the time to share these things with you. Bye for now.